All right, thank you, Melanie. All right, so this stuff here, we are skipping section 7.5, going straight to 7.6. Really, this is just a variation of stuff you've already seen. Okay, so last time we talked about the trig functions, we talked about the amplitude. And basically the amplitude is from here to here. So from the middle line here, the 0 up to the max, and it's the same thing this way. So basically it's half the distance from your highest point to your lowest point. Okay, and that's going to come into play when we move these things up and down and left and right. And that's what we're talking about here when it says translating trigonometric functions. That's what we're talking about. Translating means left, right, up, down, just like it does for any other function. Okay. All right, so this says sketch the graph of each function. All right, so this works the same way as it did before, and of course we'll be breaking out Desmos here ever so shortly. But this is the same as, remember when we talk about putting something in with the x. We've talked about this with other functions. When you put something in with the x, it moves you left and right, but it goes the opposite of what you think. So here we have moved pi over 4, okay, or 45 degrees, but we've moved to the right and not the left because it does the opposite of what we think. Same thing over here. So this is 3 pi over 4. So again, if we plug in 180 here, that'd be 225 degrees that we've shifted. But this one is going to shift to the left rather than the right. Okay? If there's no number here or here, which there isn't in this case, that means it's 1, and that means we have the standard period of 2 pi. But it will get shifted over by these guys. And then this guy, there's no number here, so this is going to bounce between +1 and -1, and this one here has a 2 in front, so it'll bounce between +2 and -2. Let's go ahead and get out the des and take a look here. All right, so let's bring it in. All right, so this one here, so we had cosine, right? So let's go cosine. Bring this up here, go over here to the functions, find the trig functions, there's our cosine. And then this was x. So let's just do the cosine x just for starters. And then we'll put it in so you can see the shift going on. So let's do that. So then we got cosine here, we got our x minus, and what was it, pi over 4? I forget already. I'm not surprised though. Yeah, pi over 4. Okay. So then minus, and I think we got a pi on this thing. Let me check. Miscellaneous. Got a pi on here? Oh, there it is. It's down in the corner. Never mind. We don't want it outside. We want it inside. All right, so then we're going to go pi and then divided by 4. So there you see the shift. We don't need a 0 there. That's going to go away. There we go. So as predicted, since this is minus, this pushes us forward. So notice here that we top out at 0, 1, and over here we tap out at the top at pi over 4, 1. So we shifted to the right, pi over 4. Let's get this guy out of the way so we can see. So does that make sense? So it's not any different than any other function. It moves it left and right. So in this case, it moved us to the right. And if we were doing degree measures, it would have moved us over 45 degrees. Now, as we predicted, the period is 2 pi, right? So one cycle goes down and then back up, and when it goes back up again, notice where we're at. We're at 2 pi. Okay? And it'd be the same thing here, except moved over slightly. Okay? So this one here, we're at pi over 4, and here we're at 9 pi over 4. And if you do pi, if you do 2 pi and make it fourths, it's 8/4 plus another one is 9/4. So that's the shift. But like I say, it gets a little confusing with the pi numbers. Okay? Does that make sense so far? Cool. All right, so let's take a look at the other one. So that one, I'm going to have something different here. I know that. I think it's plus. So put plus. All right, so there's our original in red. Now our new guy, we got a 2 out front and then 3 pi over 4. Okay. So we'll put a 2 out front. So this will be twice as high. And then this time we're going to move to the left. So it's going to be 3 and then times pi. So times pi. And then divided by oh, see, now I didn't take the whole thing. So I may have to put some extra parentheses in here. So let's do so like that. And whoops, now divide by 4. There we go. Okay. So again, notice what happened here. This guy goes between 2 and -2. And in our original, our highest point is at 1. And that's at 0. And then this guy, we go back here, minus 3 pi over 4. Because if you throw minus 3 pi over 4 right here, you get minus 3 pi over 4 plus 3 pi over 4. This whole thing becomes 0. So you get the cosine of 0, and we know the cosine of 0 is 1. So that's why it's just up here at 2. Okay? So again, the thing to remember is that it doesn't matter what kind of function it is, even these trig functions, when you're talking about transformations, they all work the same. Okay? So in this case, if we put a guy in here and it's positive, we're going to go to the left. If it's negative, it's going to go to the right. This guy out here just tells you how tall your roller coaster is. Okay? So this is where Desmos comes in really handy for looking at this kind of stuff. Did you imagine me trying to draw this thing? Yeah, me neither. So that's the story with those two. All right, so let's look at the next couple. All right, so a little more going on here. So we've got the 1/3. So this is going to be the kiddie coaster, right? This will be the big people's coaster, right? This is going to move us to the left, pi over 2. This is going to move us to the right, pi over 6. And then what do these guys do? What's this -2 going to do in the first one? How's that going to move us? This guy's going to move us left or right. What's this guy going to do? How's he going to move us? Think about any other function we've talked about. They're all the same. This stuff is all the same. Up and down, right? So since he's -2, that's just going to move the whole thing down too, right? Perfect. Okay, so this is what I try to present to you guys, and I think a lot of people that are quote-unquote math teachers, because I don't really consider myself a math teacher, I'm just an engineer helping you guys out with some math. Okay. They don't try to make the connections for you guys. They just expect you to memorize everything, and that's silly, because you remember stuff better if you've done a procedure with it, right? So I'm trying to make the connections where you don't have to remember so much stuff. It's just logically, here's what's going to happen. You know, so as I've been preaching all through this class, pretty much Algebra 2 is just introducing different kinds of functions. You know, we talked about the linears, the quadratics, the logarithmic, the exponentials, all this different kinds of stuff, right? Cube functions, square root functions, all these guys that we've talked about. This stuff all works the same. If you tack a number on the end and he's -2, we're going down 2. So how's this guy going to move? If we tack this guy onto the function, where are we going? Up 1, right? Perfect. Okay. So let's go ahead and break out the des again. Take a look at this guy. All right, so we got 1/3 and then pi over 2. All right, so this guy will become 1/3. So that's going to be 1. It's nice how the divided by turns it into a fraction. That's pretty sweet, to be honest. It's 1/3. So we got the kitty coaster going, right? And then this was pi over 2, I believe. All right. And move over here. Do that. That's pi over 4, but we want pi over 2. There we go. Okay, so let's make sure we put that guy in, right? 1/3, yeah, plus pi over 2. Okay, so again, let's get this guy out of the way so we can talk a little bit. What do we got going on here? Let's zoom it in here a little bit. So again, this guy is going to top out at 1, bottom out at -1. All right, so what about our new guy? So he's going to top out here at 0.333 positive, so that's 1/3 positive, 1/3 negative, right? And notice that when that happens, we are at negative pi over 2, which again, if you plug in negative pi over 2 right here, then this whole thing becomes 0, and it's like moving back to the cosine of 0, which was our starting point here. And so we have a smaller wave. Now the period is still the same. Okay, so this guy here, let's go back here a little bit so we can see better. Actually, no, let's back out. I was going the wrong way. So anyway, with the cosine function, you take the dip down, you come back up. So it's still 2 pi. That's because we haven't put any numbers in front of the x. So your standard period is still 2 pi. Same thing with this guy. If we start here, right, so that's negative pi over 2. Then we come all the way over here and we go back up. That's 3 pi over 2. So that's 1.5. This is negative 0.5. You put those two together, it's 2 pi. So it's still the same amount of time to complete one wave. Okay, so that's what's going on there. Questions? So I want you guys to see how this connects to every other freaking function that we've done in here, okay? It's all the same stuff. If you put a number in with the x, you go left and right. You tack a number on the end, you go up and down. Okay, so we haven't tacked on the number, but we're going to do that here now. So we just wanted to kind of go over that part. And then what number were we tacking on? -2. So now the graph in green, or not green, listen to me, blue, is going to drop down too. There he goes. So now he's dropped down too. So originally we were up here, the highest point was positive 1/3. We dropped down 2, now it's minus 1.67. So that's negative 1 2/3. And if you take 1/3 and subtract off 2, you'll get negative 1 2/3. Okay. Yeah, I know, I don't like fractions either. But then the same deal, you come over here, 2 pi later, we're back up to that high point, and then our low point is going to be -2 plus another third, so that's -2 1/3, which is 2.33. Okay? So it did exactly like what we did before. Okay, so our next guy was a sine function, actually. So let's break him out. So this one was 3 sine. So we got 3. Go find our sine function. And we go sine. Trig functions, there we go. sine, and we'll start with x. All right, so there's our original guy. Let's get him out of the way. So if you just had 3 sine x, that means we're bebopping between so our high point is going to be 3, right? And our low point is going to be -3. Right? And the sine function starts at 0, goes up, then down, and then back to 0, 2 pi later. Okay? Cool. All right, so next thing we're going in here, I think it was minus pi over 6. So we'll go minus, I think we'll go minus, and let's find our pi function again. There's pi divided by 6. Okay, so that shifted us to the right, pi over 6, or 30 degrees if you're using degrees. So move this over a little bit. And our last part, I think, was just add 1. Yeah. So we're going to add 1. So that means the whole graph is going to get lifted up. So that's equals plus 1. There we go. All right, so then this guy, originally, before we moved it, it bounced back and forth between 3 and -3. Well, now it's going to bounce back and forth between 4 and -2, because if you have 3 and you add 1, you get 4, and if you have -3 and you add 1, you get -2. So just move the whole thing up. Okay? So let's go ahead and get rid of these guys, and I'm going to turn this guy into a sine function. So I don't know what just happened there. So let's call him sine, that way we can kind of compare the two. All right, there we go, and there we go. All right, so there we are. So again, what happened here is this guy's now taller, then we moved him up 1, and we shifted him to the right, pi over 6. So he shifted over a little bit and moved up 1. Okay? And we got an extra parenthesis there we don't need. There we are. Okay? So again, the guy up front makes you taller. The guy here shifts us forward, pi over 6, and this guy shifts us up 1. Boom, that's it. Questions? So again, a good way to learn this stuff is to go to Desmos and just kind of pop things in and out and see what happens. You can definitely get a lot out of Desmos. All right, so let's continue on. All right, identify the amplitude, period, phase shift. Phase shift is another fancy way of saying left and right. And vertical shift, which is up and down. And the minimum and maximum values of the function. Okay. So, let's start with this. So, the amplitude. What's the amplitude of number 20? Keeping in mind that it's the number in front of the sine or the cosine function. So what's our amplitude here? Yeah, 2/3. It's that easy. It is that easy. So again, we said the amplitude in this case is 2/3, right? Okay, then it says the period. Well, there's no number in front of the x, so this is 1. So our period automatically is 2 pi. And remember, if there is a number there, that's when we take 2 pi and divide it by that number. Okay, so period, check. Phase shift, that's this guy. So that's going to be pi over 3 to the left. Okay? And then vertical shift is just going to be this guy. All right? So that's going to be 3 up. Okay, and that's every motion you can do on this thing. We've moved him up, we've moved him left, we've moved him, made him squash down a little bit, and the period stayed the same, so we're all good. Okay, so min and maximum values. So the original values would have bounced between 2/3 and -2/3, right? So 2/3 would be our max, and then -2/3 would be our min. But then we had to add 3 to it. So we add 3 here, we add 3 here. So this would be 2 2/3, or 3 2/3. So it would be 3.67 roughly. That's our max. And down here, we'd have 2/3 and then plus 3, but it's -2/3, so that's subtracting it off, right? So this thing would bottom out at 2 1/3, right? So 2.33 would be your min. And that's everybody. So I'm going to duplicate this slide so we can do 21. Probably should have done that before I got started, but that's all right. That's not duplicated. You need to go away. You need to be duplicated. All right. All right, so let me clean this up, and then we'll go ahead and take a look at that one. But like I said, you've seen everything there is to see as far as moving these guys around. Why is this not erasing? Starting to bum me out, not gonna lie. Why do you not erase? All right, let's do it this way then. Wow, still doesn't work. Bummer. Try one more time. There it is, finally. I don't know if I had a glitch on this thing or if it was just kind of behind the times or what. There we go, that's better. All right, so let's go ahead and talk about 21. So what's our amplitude on this guy? So the first one, the amplitude was 2/3. What's our amplitude on this guy? Yeah, 1/2. So amplitude is 1/2. All right. So the amplitude is 1/2. All right, the period. Notice this time we do have a number in front here, don't we? So that means that the period is going to be 2 pi, because that's the standard for cosine, divided by 2. So our period this time is going to be pi. That's our period. Okay? So it's going twice as fast, so we get there in half the time. Cool? All right, so then our phase shift here is going to be pi over 4 to the right. And finally, our vertical shift is going to be down 1. So down 1. That's it. So the only other thing they wanted to know was a max and the min, right? So we got the max, we got the min. Okay. So what we do then is we say, okay, this original guy is going to bounce around between positive 1/2 and negative 1/2, right? But then we went and subtracted 1 off of both these guys, right? So our new max is going to be negative 1/2, right? Because we have 1/2 minus 1 is negative 1/2. And down here, we're going to have minus 1/2 minus 2 more halves will be minus 3 halves or minus 1.5. I'm good either way. So that's your min and your max. Cool? So again, you just take whatever your amplitude was and subtract off this guy. It was the same thing for this one. We had 2/3 and then we added that guy. And that'll tell you your mins and your max. So if you add your amplitude and your vertical shift, that gives you mins and maxes. Add and subtract it. Well, I mean, it's add and subtract it because of the minimum and the maximum. Okay. Questions on that one? Sweet. All right. Check out a couple more. We'll call it a day. All right. So it says write an equation for the function represented by using the sine function. So they're going to tell us this is a sine function. All right. So it's going to be sine. All right. So next thing we need to do is figure out the amplitude, right? So the highest we go is 3/2, right? That's our max right here. And it looks like the lowest we go is 1/2, right? So what that tells us is if we're going between 3/2 and 1/2, so it's 1.5 minus 0.5, that's just 1. And our amplitude is going to be half the distance from the minimum to the maximum, which we just figured out is 1. So that means out in front of this guy, there's going to be a 1/2. Okay? So that means our original function was bouncing back and forth between 1/2 and -1/2, right? So that would have been like here and here. So what happened here? The thing's been moved up, right? So we're going to put this part here. Well, we now know that it got moved up 1, so there's going to be a +1 on the outside. So this is kind of like a fact-finding mission, right? Okay, so that's where we're at now. So we know that originally it bounced back and forth between +1/2 and -1/2, but then we added 1. That makes it bounce back and forth between 2/3, or not 2/3, 3/2 and 1/2. Okay, so again, if we add 1/2 to 1, we get 3/2. If we add -1/2 to 1, we get 1/2. So that makes sense. All right, so next thing we got to figure out is it's a sine function, right? So we have to do one complete revolution of what's going on here, right? And then until it repeats. All right, so if you look at this, it's going to repeat. Looks like we start here at 0. Looks like it's going to repeat at 2 pi. So that means that our period is 2 pi. If our period's 2 pi, that means we don't have any numbers here. So technically this is a 1, but we don't have to put him in there. Okay? All right, so next thing we got an x here. So I'm going to go back to actual drawing. Now, normally a sine function starts at 0, right? But this guy's starting at 3/2. All right, so we know we got moved up 1, so there's 1, right? But it's still off a little bit, isn't it? So if we start at 1 for y, notice that we've gone to the right pi over 2, because that would be our starting point on a normal function that's been moved up 1. Okay, so since it went to the right, then we're going to use the opposite sign and do pi over 2. And this is your entire function. A lot of things going on there, but a lot of just very small things that are pretty easy to kind of piece together, right? All right. Does that make sense? And I'm sure we'll be practicing this some more. This will wrap up chapter 7, and we'll probably do some review next week. Okay. All right, so what else do we got here? Okay, so just a couple more en route. Okay, it says select all true statements about the function. So they got everything going on here, right? So the amplitude is 3/4. Yes or no? True or false? T or F? So we know the amplitude is the number out in front of the cosine. So yeah, I think we're good there. So check on that one. The period is 3. What do you think, true or false? Nope, because the period would be 2 pi divided by 3, right? So yeah, he's out. Next one says the phase shift is pi over 6 units to the right. True or false? Yes or no? Yeah, they got you on that one. Remember, this moves the opposite way. So we see plus pi over 6, we're thinking right, but it's really to the left. Yeah, remember that? So this guy's out. Okay. All right, so vertical shift of 5 units down. How we feeling about that one? Yeah, that one's good. So we'll check that one. Okay, so the midline is x equals minus 5. Okay, that's wrong because the midline is going to be going this way. And if you've got a flat line going this way, it's y equals some number. Okay, and it would be minus 5 if it was y equals minus 5. But x equals minus 5 goes up and down, so he's out. Okay, so whatever this is also your midline, because then you're going to go up 3/4 from there for a max and down 3/4 from minus 5 for your min. Make sense? But like I said, this guy here is a vertical line. So he can't be your mid guy. Good. That's kind of a nice summation of everything right there. That's pretty good. That's a pretty good problem. All right, one more and we're out. Looks like we'll get to finish up early today. All right, so here we have this graph function. It says, but she forgot to label the x-axis. What is the value for d on the x-axis? Okay, so let's see what she's got going on here. So originally we'd have bounced back and forth between 2 and -2, right? But then we subtracted 1, so that brought us down 1 here to +1 and down here to -3. Okay, so we've taken care of that, right? So we said a sine function, let me clean this up a little bit before we move on. So we said before that a sine function starts at 0, right? But notice we're up pretty high here. Why is that? Because of this guy. Hang on, I'm not in writing mode again. So because of this guy, right? So that's going to move us pi over 2 to the left. And if you go over to here, we say we start at 0. Well, this is 0, so this must be pi over 2 right there. Okay? All right, so if he is negative pi over 2, right? Should be negative pi over 2. All right. And we don't have a number here, so that means that our value for the period is 2 pi, right? Because there's no number in front of the x. So 2 pi is our period. All right, so that means over here is going to be 2 pi from this guy. If he's negative pi over 2, then this guy is going to be negative, or not negative, positive 3 pi over 2, which is just taking negative pi over 2 and adding 2 pi to it. So that's that guy. All right. So that's our 0 points, right? So then our high points here is going to be at 0 and 2 pi, right? So this guy's 2 pi. So this is halfway in between, right? So it says, what is the value of d? Well, if it's halfway between 0 and 2 pi, then d must be pi. Okay? And that's b. So since d was our minimum and we have a standard period of 2 pi, then that minimum has to be pi. We good? All right. Well, ladies, that's all I've got for you for today. So again, like I said, we'll do some of this review next time. But again, I appreciate you coming by. And hey, it's Thursday already, so you don't have to come back till next week. All right, so we'll shut down the recording. Again, I'll thank you all for being here.